Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
It's a pleasure to have Paul back in Cambridge. Some of you might recall Paul was here in Cambridge for many years in the 90s, right? In the Faculty of Economics. It's a pleasure to have you back. You have 1 hour.
Thank you very much. Well, it's a huge pleasure to be back in Cambridge, UK. It's also my first time in Microsoft Research in Cambridge, UK. I've been to Microsoft Research in Cambridge, US, and I've been to Microsoft Research in Redmond. And this is my first visit here, and it's a huge pleasure. I've always particularly enjoyed the slogan of Microsoft Research, turning ideas into reality, because I've always thought that what we do as academics is essentially turning reality back into ideas. And so I think we have a nice money pump going between you and us. And I hope that we can contribute to our side of the money pump. So what I'm mainly going to talk about today is a paper that I've done with Mark Glick, Greg Richards, and Margarita Sapoznikoff, using Microsoft data to examine the effect of PageRank on click-through rates in online search. But I'm going to try and spend the first 10 or 15 minutes of the talk locating that apparently rather narrow empirical issue in the context of a wider set of questions that have become to fascinate, some people would say obsess me, which are about the notion of scarce attention, scarce psychological attention as an economic resource. And so the outline of what I want to cover is essentially that I'll set out why I think that's an interesting set of questions, and I'll present a number of puzzles that those questions are raising, which are not necessarily going to be directly related to the topic of the empirical paper. Then I'm going to describe the empirical paper, and in particular I'm going to suggest that although the paper sets out principally to do one thing, which is simply to say causally how much does the rank that a domain appears in the search engine results page impact the willingness of searchers to click on the resulting domain, which has obvious implications for ongoing antitrust investigations, amongst other things, that there's actually a way in which you can look at those data that start to illuminate how much the effect of location on a page has to do with the psychological mechanisms of scarce attention. And so I'm going to kind of develop it in that sense. So the overall talk will be, as it were, setting a very big scene where you may have a bit of difficulty seeing what that's got to do with examining search engine results pages. Then I'm going to set out the empirical investigation and try at the end to show why the two things are very closely related. So having given the overview, I'm going to describe how we can think about PageRank in online search, and to try and distinguish two ways in which rank might matter. It might matter because essentially high rank is conspicuous given the way in which users look at a page, and it might matter because it's signaling something that economists are more used to, which is the reputation of domains that would be in a particular rank. And then I'm going to suggest just a very simple analytical way of investigating that, show you the data that we've got, and give you the results. So that's the plan. Oh, and I can use this now, can't I? So let me briefly outline why I'm fascinated by the economics of scarce attention. It's been known, I think, since Herbert Simon, his nice pithy aphorism that a wealth of information creates a poverty of attention. But of course, not until the internet and the sensation we all have that our email inboxes are bursting with more stuff than we can handle, that this has really started to become a major concern for researchers. And in particular, I think there's a converging set of interests between people working in psychology, and particularly in neuroscience, and people working in economics to treat this as a really interesting problem. As a bit of advertising, we held a fascinating workshop in Toulouse in September, to which Sanjeev came, among other people, in which we brought together 7 or 8 neuroscientists, some social psychologists, and some economists to discuss the psychology and economics of scarce attention. If you go to the Toulouse website, you can actually get a summary of that. And one of the things we were interested in was whether there was a a parallel between the kind of mechanisms that neuroscientists look at, in which the attention of individuals can be easily exploited when they're looking at rather short-term things that happen on a screen. Neuroscientists love setting up experiments. Some of you will have heard of the invisible gorilla videos, which essentially manipulate the attention of users to things that are going on in a visual field over time scales of perhaps 10, 15 seconds. And a phenomenon which has become of great interest to the wider public, which is why economists have failed to spot events like looming financial crises, which it's now fashionable to say were there in the data all along, but which somehow or other the collective attention of the profession hid from view. And although I won't claim that our little workshop actually managed to resolve those things properly, not least because the neuroscientists kept saying, we don't really understand time spans of longer than 20 seconds. And you're saying, why was there a blind spot in the visual field that lasted 10 years? Nevertheless, I think we had some very interesting interactions, and that is going to continue. I mean, there are some... I have a project, actually, with a neuroscientist in Oxford going on topics, and there are other kinds of interactions that are likely to follow from that. Some of you might know a very nice book by a psychologist called Torkel Klingberg called The Overflowing Brain. It's a beautiful title and expresses pretty much what many of us, certainly I feel, the sort of sinking feeling as I open my inbox in the morning. And a kind of sense that people can't quite really analyze and can't quite put into words, that all this information hasn't entirely made us better off. But as I say, the tack that neuroscientists have tended to take is the way in which, first of all, our attention can be manipulated by others without our really knowing. You know, certain kinds of manipulations can slip under the radar of our attention allocation mechanisms, and most importantly, the fact that we're so little aware of our attention deficits. A lot of the manipulations that neuroscientists are interested in focus on the fact that we think that we have an awareness of what's going on in our complete visual field, and we're not, our higher level of awareness is very limited about the extent to which, for example, our brain is filling in information across things like the blind spot where the optic nerve meets the retina. So those are the kind of issues that tend to interest the neuroscientists. Economists are, for obvious reasons, interested in questions of optimal allocation. In particular, there's a number of papers now by economists thinking about the allocation of attention as a little bit like an overfishing problem. The idea is that, in some sense, advertisers have access to the common pool of our limited attention, and there's a sense in which there are too many advertisers fishing in this common pool. And of course, marketers are extremely interested because they want to know how to fish better, but I guess from a sort of point of view of our collective welfare, we'd like to know whether there's any element of misallocation involved in the way the fishing goes on. So let me just mention a couple of puzzles about scarce attention. Couple of informal claims that I've heard often, in sort of economists have talked about them, but which become a little bit more difficult to understand when you look at them more carefully. So one of the things that labor economists talk about is that employers who in the old days might have had, they might have put an ad in a newspaper and a few people would reply to their ad, and they would then be able to examine those applications fairly fully, including perhaps interviewing everybody. Now they put an online ad and they get thousands and thousands of applications, and so they can't possibly interview everybody, so they turn to rather crude screening mechanisms, including things that have to do with implicit networks and perhaps gender, race, all sorts of criteria that may come in, and which cause them to give less good scrutiny to the many applications that they get than they would have got in the old days when they received fewer applications. Similar argument I hear from my colleagues all the time. Professors, they say, well, I'm constantly getting email requests from students suggesting, can I look at this paper, can I look at that paper? I end up in the end processing fewer good ideas than in the old days when I insisted that students came to my offices in person. How can it be that greater ease of communication with me is somehow worsening the quality pool, the pool of the quality of ideas, the quality of the pool of ideas that I receive? And this poses an obvious problem for economists thinking about how can greater choice, a larger set of things to choose among, how can that lead to lower utility for the chooser in the absence of strategic effects? We all know about how restricting your choice set can give you strategic advantages, but the questions are how can it actually, without those strategic advantages, how can simply having the larger choice set make you worse off? Well, there are two obvious things that might occur to an economist. One would be that there might be straightforward processing costs. Perhaps it just is that all of those emails coming into the inbox have to, I certainly spend several hours a day, indeed a substantial amount of time every day, sort of patiently explaining to people why I can't do what they've asked me to do. And maybe there's just a certain processing cost and maybe the overfishing problem comes from the fact that somebody can make a claim in your attention that you can't screen out and simply oblige you to spend some time dealing with that you wouldn't have had to spend before. Now, for obvious reasons, that's not very satisfactory because it implies that we're not able to use relatively low-cost ways of cutting down the pool of alternatives to choose from. If it really is very costly to process 10,000 job applications, and if in the old days when we received just 20 job applications because we put an ad in the newspaper instead of online, well, presumably we could just choose 20 random job applications, look at those and ignore the rest. Now, there are some arguments that suggest that there may be institutional obstacles to that. Maybe there are rules about fair treatment of people who've applied to you for a job which suggest that you can't simply ignore the all but the first randomly selected 20 job applications. Maybe there are issues about the reputation of the employer that suggest that at least they have to send a polite message to people who've applied to them and that this involves certain costs. But again, it's not very satisfactory just to conjure those processing costs out of the air. So I think a more reasonable explanation has to do with statistical externalities, the idea that the larger pool of items to process actually reduces the expected value of processing from the pool compared to a situation in which you received fewer items in your choice set. So here's a little toy example which would talk about statistical externalities in job search. This is based on some ongoing, work just begun with a PhD student called Ananya Sen in Toulouse. Essentially, think of two firms that each exist in a company town. Okay, so firms A and B, and workers can be of two types. They can be little a, little b. And the important point is that there has to be matching of types of firm to types of workers. So you can imagine a firm that does relatively manual work, engineering type work, another that does relatively service type work, perhaps software based. And what you need is you need to match the right type of worker to the job. So matches of firm A and worker type A yield a positive surplus. Similarly, matches of firm B and worker B yield a positive surplus. But if you match them wrongly, firm A and worker B, or firm B and worker A, then you get negative surplus. So it's important to the employer to try and work out what type of worker you have. Now, suppose that for historical reasons, perhaps to do with the firms, the towns being company towns, in the town of firm A, workers are more likely than average, they have a probability higher than half, to be of the appropriate type, little a. Perhaps they're the sons of the people who used to work for the firm in the past, and there's some genetic or environmental transmission from generation to generation. Similarly, in town B, the workers are more likely to be of type little b. And in the old days, when it was very hard to move from town to town, when you actually had to sort of get up and get on your horse or get on your bike and move to the other town, then it was simply too costly for most workers to go and apply for a job in the other town. Now, transport costs fall, or you can pick up the phone, or you can simply apply on the internet. Everybody applies on the internet. And what happens, both types of workers apply to both towns, and now suddenly, it's not possible for the employers to say, well, we're going to simply pick randomly. Even if it's costly for us to screen the workers, we're not going to pick them at random because now the probability that the worker is the right type for us has fallen from P, which used to be above a half, it's now fallen to a half. Okay, so what you get then is a situation in which you don't just get the familiar kind of congestion externality which we know about in the labor market literature, that more workers applying to firms imposes a negative externality on the other workers who would previously have applied to those firms. Now the externality is also inflicted on the employer because the employer now receives a statistical cost, which is the fact that the larger pool of applicants makes it harder to screen for those who in the old days would have had some slight probability of being appropriate. So when you match a situation of falling communication or transport costs with a pre-existing propensity or affinity through some kind of prior assortative matching, which disappears because the larger pool of applicants no longer shares that assortative characteristic, then you can see how essentially having more choice makes the firms worse off on average. Okay, so that just gives you an example of why the scarce attention that why scarce attention is a problem for an employer that they can't simply resolve by using some kind of arbitrary screening rule, like saying, in the old days we only had 20 applicants and we could interview them all, so we're going to take the first 20 online applications and interview them all, because the first 20 online applications will not have the same statistical properties as the old 20 applications used to have. Okay, so that's the big picture stuff, and you may think this isn't rather irrelevant to what's going on here, but what I want to do is now to try and zero in on what search behavior tells us about how individuals actually reason and screen the very large number of options that come their way, and in particular how it is that search engines help them to do that. So let me start from the very commonplace observation, which you see in the press all the time, that domains that are ranked high on a search engine results page tend to get a higher click-through rate than those that are ranked lower down. And that's commonly said to be, that's how Google makes its money. Essentially, Google is an entire money-making machine based on the idea that it can sell the slots higher up the results page for more money because those who are willing to pay more money believe that being higher up the advertising rank gives them more click-through, and they also believe that on the algorithmic results ranking, being higher up the rank leads to higher click-through rates. And that's why, for example, Google is under investigation at the moment, based on the idea that it's in some way distorting the results of its algorithmic search to favor its own sites, its own map sites, for example. Those are something we don't take a view on that in our paper. We look at the much more straightforward empirical question of whether it's being higher up on the search engine results page that causes the higher click-through rates, or whether, as seems an obvious, plausible alternative hypothesis, a search engine that's doing its job will simply put high up on the results page those sites that, for other reasons, would have the qualities that would lead the searchers to click on them with higher probability in the first place. So there's an obvious two-way causality. Okay? It may be that being higher up on the algorithmic results rank makes people click on the domain with greater probability. It may also be that the search engine, in doing its job, is in some sense predicting that that those who search will click, and all we're observing is something like successful weather forecasting, rather than, we don't believe that successful weather forecasters cause the weather. We just believe that they're very good at foreseeing the weather that's going to come. So how are we going to tell? Well, that's something which I'll show you how we do that in a moment. It's essentially through trying to use domain fixed effects to control for the fact that there'll be unobserved characteristics of those domains that should be able to predict, or that will be causing some of the variance in click-through rates. And by controlling for those fixed effects, we would expect to be able to measure separately the impact of being in a higher or lower place on the results page. But it's going to be a little bit more complicated than that, because as you'll see in a moment, in order to get the necessary variation in the ranking of results of domains on a page, we have to have a view about what's causing variations in that ranking. And we have to have the view that those are genuinely exogenous to factors that may be affecting the willingness of users to click through to the domain. Now, the link of all of this with scarce attention is going to be that what interests us, if we can show an effect of click-through, of rank on click-through rate, as we believe we can, we want to know what's doing it. Is it the reputation attached to being high rank, or is it the conspicuousness attached to being high rank? To put it simply, is it that busy users see a domain ranked high and then click on it because it's ranked high? Or is it because they see the whole page, they take in the whole page, they reflect on the whole page, and they reason from past experience that sites ranked high on the page are likely to be more relevant to their needs? In other words, can we use the data to distinguish between the view that, in some sense, the top spots on the page are attracting the attention of users who then take a decision based on that limited attention, or that they reason in a much more complete way on the basis of the properties of the entire page and the reputational characteristics attached to being in different slots on the page. So the way we come at this is by thinking of a very simple process in which the rank of a brand, the rank of a domain and the reputational characteristics of that domain impact the probability that an individual user clicks on the domain. So think of a search engine results page that generates, let's say, 10 different domains in response to a query term. And I'm going to denote C of I and R as the probability that a domain is clicked on, which is a function of two things: its rank, I, and its visible characteristics, the things that people might know about it. Okay, so if it's a famous name, if it's Facebook or Yahoo or whatever, there'll be a whole lot of things associated with that in the mind of the user. And we simply divide that into this very simple expression. The idea, something we call the catching effect of rank. And by the catching effect of rank, we mean simply the probability that being in a particular rank attracts the attention of the user, multiplied by what we call the holding effect of the brand. The probability that having had your attention drawn to the domain in that particular spot, you will then make a decision to click through based on what you know about the characteristics of the domain. Okay? Now, if you don't click through based on what you know about the characteristics of the domain and the fact that your attention has been drawn to that spot in the ranking, that's to say with probability 1 minus Q of R, then there may be a holding effect of rank. Okay? You haven't heard of this website before, but given that you're there, maybe the fact that it's in slot number 1 or slot number 2, by that very fact, is going to cause you to click through. Okay, so that's the total. So we divide, in a sense, the factors that make the difference to those which are based on the characteristics of the domain once your attention has been drawn to it, and the fact of being in the particular slot that it is. Okay?
Are you just thinking about click-through on sponsored ad slots or about just a general search result?
No, this is on the algorithmic results. And as you'll see in the data in a moment, we essentially we try and use queries that are not heavily monetized. So we avoid ones where there's an interaction between sponsored ads and algorithmic results, just simply in order to get a cleaner effect. Of course, in many real cases, there's going to be an interaction between the two. Now, you can then very simply take, yes?
Could you go one step back?
Sure.
So I didn't fully understand why you believe you can factor these two holding effects in this particular way. Couldn't there also be a joint effect that you have a holding effect from the brand and from the rank? So
they may both be.
There's an interaction between the two. So I don't.
Yeah. No, I mean they'll.
Only multiplying it with the. Or you're only multiplying it the holding effect.
No, it's just that, I mean, this is just decomposing the thing is that once your attention has been attracted to the domain that is in, say, rank 3, okay, either the information that you perceive in rank 3 is sufficient to ensure that you click on it, or it isn't, in which case the effect of the rank may be. This is a decomposition. This is, as it were, a definition rather than a. This isn't a behavioral equation. This is a decomposition of that overall probability into two things.
Oh, but I mean, your model says something like, will you look at location number 3? That's the catching effect of rank.
Yeah.
If you look at that location, will you like whatever is listed there? If
Yeah.
you like it, you will definitely go in.
Yeah.
If you don't like it, you might think, that's your last part, you might think, well, it's in location 3, it might be important, I will go in.
Exactly.
But it's saying, well, these two might be related. It could be the case that what appears in rank 3 is more likely to be relevant to you.
Absolutely, yeah, no, exactly, and that's what we're going to look at the interactions here, in which, in particular, we want to look and see what the cross derivative of the click probability with respect to both rank and brand is, and it's precisely those interactions that are going to interest us and that we're going to try and use the data to think about. So, if you take a cross derivative like that, this is simply mechanically what comes out. And the interesting polar cases, which are going to help us to think about this, is what happens if attention isn't scarce. Okay? Now, look back at this. The catching effect of rank is the probability of having your attention drawn to a domain by its being in a particular rank. If attention is not scarce, so that you can essentially you can look at all of the ranks on a page, okay? Then pi is going to be identically 1 for all I. Okay? And correspondingly, the derivative of pi with respect to I is going to be 0. So in the expression here, we can replace p dot of I with 0, pi with 1, and then it simply drops out that if attention isn't scarce, the cross-partial derivative here is simply minus the derivative of q with respect to r multiplied by the derivative of t with respect to I, and that's going, since both of those terms are strictly positive, that cross-partial is going to be strictly negative. So a negative cross-partial derivative there is in a sense going to be evidence that attention is not scarce. If attention is scarce, that's to say p of I is not, well, we'll take the hypothesis that it's increasing in I, but brand reputation effects are 0, then that polar case simplifies instead to this expression, I beg your pardon, here, which is a strictly positive expression. And so we know that in the polar case in which attention isn't scarce, we're going to get a negative cross-partial. In the other polar case in which attention is scarce, but there's no independent effect of reputation, we're going to get a positive cross-partial. And so there's a sense in which we can use the sign of the cross-partial to give us an indication as to which of these two is in some sense more important. Is the search engine working to generate the effect it has, which we'll look at separately, on user behavior, the click-through behavior, via scarce attention, or is it going to generate that effect via reputation effects? And that's what I want to show you in the data that follow. Yeah?
Does your model consider the possibility that I search for something and then I look at the first 3 rows, I don't find the answer, and then I search again because I think that the keywords I used was wrong, and so do it again?
That's, if you mean empirically, do we look at cases where there was no click? Yes, indeed. We include essentially all of our data are an observation is a query which leads to a search engine results page. Okay, and then there will be many of those in which we know whether there was a click on one of the domains. We know the rank of the domain that was and obviously the identity of the domain that was clicked. And there will be many cases where there was no click. Yeah. I mean, what we don't have, and this might be a weakness, is we don't have the history, or at least we don't use it. I guess we perhaps could get it. We don't have the history of observations, that's to say search engine results pages where there was a click that had been preceded by one where there was not a click. And maybe there's some information in that history which we don't use. So I mean, that's a good point, which I must admit hadn't occurred to me before. Yeah?
I want to really follow up on the earlier two questions. So you seem to assume a very particular form for C of I, R. You assume this particular separability into two factors, each of which depends, all multiplicative separability, each of which depends only on one of the two factors. Is there a way in which you can test in your data whether this model makes sense statistically, or could it be that a bunch of the results that you find are coming out of that specific assumption that you have this multiplicative separability?
Well, I mean, I'm not sure I understand exactly the question, because this is in some sense...
Right here you have functions, so you could not particular functional forms. For instance, if for particularly small or particularly large Q, the holding effect of the rank does not matter very much, but for medium range values of Q of R, it matters a lot. If this were what the world looked like, you would not be able to capture it. If you now fit the parameters, it would somehow come up with some linear approximation to this behavior, which may be far from what you actually observe in the data.
Okay, well, let me put it this. This is put forward, as it were, more as a definition than as, I mean, this is not a behavioral equation. This is simply saying, look how we decompose the effect of rank and reputation on the probability of clicking. We decompose it, and that, in a sense, defines for us what we mean by the holding effect and what we mean by the of rank and what we mean by the catching effect of rank. Now, I guess that you're saying that decomposition may not be stable in some ways because we don't know that the holding effect of rank is going to be, that T of I is going to be independent of R. Yeah? Right, okay. And I'm not sure how straight, well, I think what we could do, actually, this would be a good suggestion, which we haven't done, would be, for example, to do the same econometric exercise on high-ranked domains and a different econometric exercise on low-ranked domains. So yeah, that's possible. As you'll see, one of the difficulties is that we have a very skewed set of observations. We have, it's very rare, for example, for a given domain to be observed throughout the whole range of ranks. So, we'll see domains that tend to move from 1 to 3 or from 5 to 7 or something like that. And that somewhat limits our ability to do that. But I agree that that's if I've understood correctly your question, I think that's a reasonable observation. Okay, so I better get a move on. Okay, so here are the data. We have Bing log files provided by Microsoft, and for every search query, I'll explain in a moment how we have used the particular search queries we have. Whenever a search query generates a search engine results page, we have the date and the time of the query, and we have a list of domains by rank on the page, and we know which domain was clicked on. And what we did was to start with a set of relatively general query terms, and we eliminated from those all of the results that fell into a number of categories. And as you'll see, this actually eliminates quite a lot. We eliminated all search engine results pages with blended results in the top 3 ranks. Now, you know what blended results are. They're the ones where you get essentially complex multiple results. You get something with the possibility of clicking on 3 subheadings. Okay, that seemed to, since we're looking for something relatively straightforward, which is does it matter where you are on the page? Once being in rank 2 means something different if you're in a blended result than if you're in an ordinary algo result, we decided simply to get rid of those. We eliminated 4 other categories of results. Those which are heavily monetized, this comes back to your question. So queries like airline tickets, for obvious reasons, those are ones that people love to sponsor. So you get a lot of ads, and particularly since some of the ads are at the top and some of them are at the side, that again makes it more difficult to separate out the effect of location on the page. Then there are things like that are called super fresh queries. Let me illustrate the difference between. So this is something that is not a super fresh query. This is green shoes. Okay, this is the sort of thing that you get here. You'll get a range of things like that, these pictures at the bottom. And here is Obama latest approval rating. And Obama latest approval rating is constantly changing. Okay, the sites that have, a site that has just got a new result of an opinion poll, for example, will tend to shoot to the top of the ratings because people are constantly wanting to be updated, and that means that with these super fresh queries, the position of the domain on the page is likely to be endogenously related to changing perceptions of the domain's relevance over time. So we eliminated super fresh queries. We eliminated navigational queries like Facebook. Okay, if people tap Facebook into Bing, then fairly obviously, when they find Facebook, that's again going to confuse the effect of rank, where what we're interested in is if people are making some sort of general query rather than looking for a particular site. And then there are quite a lot of queries that ended up with relatively heterogeneous meanings, like eclipse, which interests astronomers but also fans of vampire novels. So there are, in the end, we ended up getting rid of quite a lot of them, and of the list we began with, we are left with 4 queries: fun games, phone numbers, free movies, and sports. And as you'll see, there is a bit of variation between the results of these things. So, we don't claim that what we're finding is something that is absolutely a kind of law of nature that's unrelated to the query term. But as you'll see, there's a reasonable amount in common between what goes on in the case of all of these queries. So those are the two. So let me show you, for example, what we get here. Here is the phone numbers query, and what you see is the top 5 domains in terms of those that appear highest, and what they look like in terms of the distribution of the ranks. So the highest is a site called phonenumber.com, and as you'll see, it does appear across almost all of the range, but it's very heavily skewed. So it appears massively in the 2 first ranks, a little bit in rank 3, and then very tiny number of times in ranks 4 to 10.
I'm confused. Where does the variation come from? Is it why do different users see the different ranks or at different times? Or?
Well, I'll show. You'll see in a moment. I'm going to show you a couple of graphs of the dynamics over time. That's part of what we're interested in, because what we want to know is it appears that, and we discuss in the paper at some length, that there are a number of causes of essentially random fluctuation of the ranking, partly because things like, it's as simple as things like maintenance of some of the servers changes the way in which the algorithm works. We checked very hard to see whether there were regional variations that might be, as you can imagine, correlated with some of the relevance that we were looking for, and we simply couldn't see any. And we were assured, and we talked quite a lot to people in Microsoft who sort of said, well, actually, these things do change, and they change for reasons that are often, as I say, they can be associated to maintenance, but they're certainly not. We were certainly very strongly assured that they're not, in the case of these general queries, brought about by a sort of real-time response to how people are clicking. Okay.
But it could be based on personalization, right? If we know something about a specific individual, sometimes we do tailor the search results.
Yes, these things, as far as we can, I'm trying to remember the dates we got. These are data that come from 2009 and 2010, and I think personalization was not as advanced. We're pretty sure that personalization isn't a big part of the story here, but again, yeah?
It could also be a time of day.
Yeah, no, there's certainly time of day effect. We control for time of day effects. You'll see in a moment. Now, so what we get here, so for example, Wikipedia here tends to come lower down the rankings and tends to be more evenly split, sort of between 5 and 8. Switchboard.com, again, high up here. any who... What it means is that there are clearly big differences in the domains, and controlling for these characteristics of the domains is going to be very important.
What was the time span of
This was over... I was afraid somebody was going to ask this, and I was chatting during the break, and I was thinking to myself, I have to go and check exactly the dates of the... And I was talking too much in the break, and so I forgot. But it was over a period of something like 3 months. But I'll check. I mean, I've got it in the paper, and if it's important, I can let you know. Okay, so estimation issues. What are the key things here? Well, the key point that I mentioned is unobserved domain relevance. Okay, there are some things that simply make this domain more relevant for this query than others. Now, if that's time invariant, we can use fixed effects estimation. The problem is what happens if it's not time invariant. We observe these variations in page rank. Could these be endogenous to changes in prior click-through rates? In other words, could it be that for some reason, a domain is being perceived as more relevant, so the click-through rates are going up and the algorithm is responding? Well, part of the response comes from what we're told about algorithm properties, but part of it comes at actually looking at the way the data behave over time. And we've done the Granger causality tests, but I think a picture tells a more compelling story than Granger causality. So this gives you, for example, actually no, I've got the answer. So it's actually, here we are, the 1st of November 2010 until 1st of January. So it's about 3 months between November 2010 and February 2011. And what you actually see here is the red is for a particular domain, white pages. It's the percentage of the daily views that that domain appeared in rank 1. Okay? And so what you see is, these are the probabilities that go up to 0.5. You see there's a fair amount of movement around, and the movement is large, but what you see here is that the changes in the page rank tend to precede the changes in the same direction in the click-through rates, which the click-through rates are here. So this, it's difficult to argue that this drop in the percentage of time that that domain was in rank 1 has been caused by a prior fall in the click-through rates. Okay? Does that make some sense? And just to show that we haven't cooked the numbers, here is phonenumber.com. Again, showing rather similar kind of thing. It's when the click-through rate goes up, when the page rank goes up, that we see the rise in the click-through rate, then it comes down again, we see a big fall, then the page rank goes up, and then we see an increase in the click-through rate. So we feel reasonably confident that if there's variation over time in click-through rates, it's not what's driving variation over time in the page ranks. So let me show you some descriptive regressions and then try and get a little bit more into the causality. So here for these, this is something that we don't, this isn't a structural estimation of any kind. This is just to give you a sense of the magnitudes of what's going on. Here what we do is we regress for given hourly time slices the average click-through rate in that hour on the average rank in that hour. And so what you see is that when we use fixed effects for domains and fixed effects for hours, all of these, for all of these queries, being in rank 1 has a substantial effect on the probability of being clicked on. Here it's 16% as opposed to only 3% if you were in rank 2. It's larger for fun games, it's 26% as opposed to 4% in being in rank 2. Free movies, it's 18%. Sports, it's much less, it's only 5%. Okay? Now, you might be interested in comparing that to the previous table, which showed the click-through rates without controlling for the fixed effects, and those are much larger. So here in phone numbers, you see the apparent it's apparently a much bigger difference, 30% being in rank 1, here 27% being in rank 1, 63% being in rank 1. If you simply were to take the averages of those, you would say, wow, you know, being in rank 1 is really, really important for you. But the point is that these are domains that are clearly perceived as relevant and often appear in rank 1. So the average click-through rate of each of these domains is a poor guide to the causal impact of being in rank 1. So that's what the fixed effects does for you. It still leaves an important causal impact of the order of, you know, between 16%, 26%, 18%, 5.3%, but still substantially, in this case, the phone numbers, that average number 16% is much smaller than it would have been if you'd simply added up the average click-through rates of the domains that appear in that rank without controlling for the domain fixed effects. Okay, now what we do is getting a little bit closer to something causal, where we use a conditional logit regression, and this time the unit of observation is not all of the observations that occur within a given hourly interval. They're each individual query that generates a search engine results page is an observation. Yes?
Yes, so just going back to the table, you know, where the domain, the previous table, just to be sure, yes, just to be sure I understand. So when phonemumber.com is ranked first,
Yeah.
as compared to when it's ranked second,
Yeah.
the click-through rate is very different.
A big one?
The click-through rate is very different.
Yes, it is different. Yeah.
Now you have, you have a fixed, you have domain fixed, you're fixing the domain.
Yeah.
So in fact, you can identify the difference in the click-through rate simply to read the rank.
Mm-hmm. Yeah, exactly. No, that's what we do. But we want to know, in a sense, the average. And the way to get the average is not simply to average across every domain in rank 1 and compare that with the average of every rank in domain in rank 2. You're completely right that for phonenumber.com, under our assumptions about exogeneity of rank, the effect is precisely determined by the difference between that proportion and that proportion. But on the other hand, we don't want to get a huge number of parameter estimates that are entirely domain specific. We want to get some general sense of what it does for you. And to get that general sense, we can't just add across or average across all the domains in rank 1 and average across all the domains in rank 2, okay? Which is, so by including the fixed effects in the OLS regressions, you immediately see that the average effect is smaller because essentially what in the case of phonenumbers.com, being in rank 2 was already likely to be compatible with a much higher click-through rate. I better get a move on, actually. So let me, okay. So here are conditional logit regressions, which now we've presented in terms of odds ratio. I won't spend more time on this table, but this is essentially telling us that there's a very, very big impact, you know, compatible with what was going on before. Many more observations, as you see here. And what I'm now going to do is to come back to the question about scarce attention by looking for these interaction effects. So what are the reputation effects that we're looking at? How can we measure them? And so what we try to do here is we say, think of the reputation of a domain as measured by its average page rank, or strictly speaking, the negative of its average page rank. If it's a domain that on average is in a high rank, we're going to treat that as some measurable characteristic of how people think about it, okay? There's going to be some measurement error there, but it seems to us the best proxy we can get. So what we do is we then give every domain a number, which is the average of its page rank across all of that period. And what we do is we therefore include for each rank in which it appears an effect of its average page rank on its click-through rate, which we measure separately from the effect of rank on its click-through rate. Since that's defined negatively, then a negative coefficient on the average page rank is going to imply that there are effects of reputation, okay? And if that negative coefficient is smaller when you see it in lower ranks, that's going to be a measure of that, a negative measure of that cross-partial that I talked about, implying, therefore, that the conspicuous effect of rank dominates the reputation effect, even though there is a reputation effect. So let's look here at the results. This is the last table. So what you're going to see here is that, so if you look at phone numbers, you're going to see an effect of being in rank 1 on the probability of clicking through. You're going to see that there's an effect of rank 2, an effect of rank 3, an effect of rank 4. These are all, remember, the unit of observation is the individual observation of a results page. And we then interact the effect of rank 1 with the mean rank of the domain that appears in rank 1. And this mean rank, you see, takes a negative value. Because we've defined reputation as being the negative of page rank, this should be understood as implying that there is, as it were, a positive effect of reputation. And the fact that this positive effect of reputation is higher in the high ranks, so it takes 12.4, 6.7, 2.4, and around 8, it falls here a little bit and falls by more as you get down. So by the time you're in rank 4, the mean rank of the domain in rank 4 has a substantially smaller impact on the probability of clicking through. That is in some sense a measure of the cross-partial effect we talked about before. It's telling us that there are reputation effects. Nevertheless, the cross-partial effect, as I described it before, is positive, and then that implies that the conspicuousness effect of rank is dominating the reputational effect of rank. So it's telling us in some sense that the real story here is that in spite of the fact that being in a high rank is a signal that a rational Bayesian user of the search engine results page does take into account, would take into account in helping them to decide where to click, there's a simple fact of having the attention drawn to a particular spot on the page which is in some sense even more important. Now I'm using that slightly loosely because we haven't said anything about what exactly you conclude. I've given you the two polar cases. I've said if attention was completely unimportant, we would see the effect would have one sign. If it was all important, we would see the other effect. We haven't, as it were, defined or calibrated what the zero cutoff point was. So I'm using the term slightly loosely when I say that the conspicuous effect dominates the reputation effect. All I mean is that that cross-partial term is closer to the one pure case than it is to the other pure case. So I don't want to claim more for the result than that. But what I do want to say that it shows is that sheer conspicuousness is playing a very important part in this story. Okay? So the user's in a hurry. The user is not looking carefully at all the results, deciding on the basis of prior experience how much weight to give, balancing that weight against what they know about the characteristics of all the domains. Essentially, many of the users are going to domain 1 and simply deciding on the basis of what they see in domain 1 without evaluating the characteristics of the domains elsewhere. Or they might go to domain 1 and domain 2 and take a decision on the basis of what they see there without evaluating the characteristics of what else is there. And that is a sign in some sense that the sheer place on the page is creating a rent. Now, of course, you may say, dynamically it's a little bit more complicated than that. How do you know where to look on the page in the first place? You know on the basis of past experience, or people tell you, if people start to tell you you're crazy just to look at the first place on the page. Actually, all of the really best results are in slot 7 or something like that. You can imagine numerologists having a lot of fun with that one. So your behavior might evolve dynamically over time. What I think this shows is that nevertheless, statically, at a moment in time, when your browsing behavior, your clicking, your querying behavior and your clicking behavior is determined by prior experience, the effect of being in a particular slot captures your scarce attention in a way that is not just about reputation. Okay, so I think that's pretty much it. What I think we've shown is that PageRank has a causal effect on click-through rates. and it doesn't merely reflect websites' intrinsic attractiveness. Now, of course, it does affect websites' intrinsic attractiveness, and that is measured by the fact that the coefficients on rank are much smaller than they would be if you simply averaged across the click-through rates for all the domains that appear in a particular rank. But so, using the fixed effects treatment is very important for getting a more realistic measure of that, the magnitude of that effect. Nevertheless, that effect is still there even when you do that. We can test for the conspicuousness effect of rank separately from the reputational effect of rank, subject to the criticism you've made that we're capturing an effect, as it were, at the mean of the sample on some assumption about separability of those effects, and that might be different at different points in the distribution of those characteristics. And we find, in the rather precise sense that I've defined, that the catching effects are stronger than the holding effects, or rather, the conspicuousness are stronger than the reputational effects, in the sense that the magnitude, the sign of the cross partial, is closer, is that of the polar case in which it's all about conspicuousness and not at all about reputation, and not of the same sign as the polar case in which it's all about reputation and not at all about conspicuousness. And that certainly implies a strong role for page design as an attention directing and capturing mechanism. Okay? It's not just about getting the algorithm right in the sense of predicting which are the websites that people are going to want to click on. It's about using the fact that the user is in a hurry, that they don't look at the whole page. They take decisions on the basis of the bits of the page they've already looked at. And that creates a strong rent to attention in a world in which users are busy people, like all of us. Thank you.
I think we have time for a couple of questions. Yes.
So one interesting distinction, I don't know whether you've done it, would be to look at conditioning based on the history of this session. So how likely is the user going to click on the second result, whether or not they have clicked on the first result? So for something like phone numbers, maybe a lot of the pages are interchangeable. So if I've clicked on the first one, it answers my question. I don't need to look at the second one.
Yeah.
Whereas for others, maybe there's only more like one right answer. So there's sort of this issue of how much is it simply that people scan from the top down, and as soon as their needs are met, they don't look at the further ones anymore, versus how much is it that they really get a reputation effect from. I don't know whether it would be a way to analyze your data, whether you have enough session data to actually distinguish between.
So, I mean, it's a great idea. And I think we'd love to do it. I don't know whether we have enough session data. I mean, it's true that there's something a bit seductive about, the sheer number of observations that you generate out of using each page as a separate observation. And if, as it were, the more individual sessions we've got, then, or rather, the more of these individual pages come from long sessions with the same query, then the fewer observations we're going to have if we treat the unit of observation as the session rather than the query. But I certainly think we ought to look at it, and it's a very useful suggestion. I mean, actually, even using an indicator function which says, is this the first time the query is made versus has the query been made previously in the session, would probably tell us something already rather useful.
Thank you very much.
Okay, thank you.